Good evening, everyone. I'm glad to have Henrik Warne here with me. And this is the last talk in the last day of PyCon Sweden 2020 Web and Education track. Henrik is a professional programmer. He has like 25 years of experience. And he would actually like to share with us his teaching experience. Henrik, you're welcome. And the stage is yours.
Okay, thank you. Yes, so almost exactly 3 years ago, I was in my son's classroom and teaching Python. And I'm not a teacher, I'm a developer, but I helped the teacher in the class to teach Python for the students. And so in this talk, I'll go through how this happened and how we planned this and how it went and what lessons we learned from it. So I'll just start by briefly talking about my background. I'm a software developer at TriOptima in Stockholm, and I work with the financial applications there. In the past, I worked at Simsoft, Tilgin, and Ericsson. And I think people know about Ericsson, but maybe not the other two companies. But they're all in the telecom space. And I've been programming for more than 25 years now. And I still love it. I still code every day. I think it's a really great job to have. And for the past 6 years, when I've been at TriOptima, I've been coding in Python. And before that, I've been using Java, C++, and Plex, which is a proprietary Ericsson language. My blog is at henrikwarne.com, and I'm also on Twitter at Henrik Warne. So 3 years ago in 2017, all the schools in Sweden were required to teach programming to all the students, and that's a really good thing. I think it's about time that they do that, but it's a problem because not all schools, not all teachers have enough knowledge to teach programming. And so another dad in the class and I, Olle actually talked to the math and technology teacher called Caroline, and he basically volunteered to help, and he volunteered me as well. But I'm happy he did, because it turned out to be a really good experience. And so Olle and I, we said that we could help Caroline get going with the course. Of course, we couldn't be there all the time and help them, but we could figure out how to teach Python programming and then help them a little bit and support them and come to the school maybe a few times. And then we took time off work. So we did this in our spare time. And Caroline, the teacher, she had some programming experience when she went to university, but that was quite a long time ago. And also, she wasn't sure what the best environment to use was. I mean, there are so many. I mean, you have to pick a language, and you have to pick like what platform should you use for it, and all the stuff like that, which makes it quite daunting to try and figure out how should I teach programming. And they'd been doing programming in Scratch, and they'd used Lego robots, but they wanted to do text-based programming. Yes. So and this was for like an 8-week period, and they had like, I don't know, 2 or 3 lessons per week during those 8 weeks. So basically, Olle and I were going to help them to get going, and then support them along the line, but not being there all the time. And so Ulla and I, we met in the evenings a few weeks before and talked about how we should do this. And we decided we should use Python. And that was for quite a few reasons. Both of us knew Python from before. I used it every day. And also, it's a good beginner language, like not too much boilerplate, pretty compact syntax. So that's a big plus. And also a really big plus was that all the students in the class, they had MacBook Air laptops. And on those, there was already Python installed. So we didn't even have to do anything. They could just open their laptops and start programming, basically. So that was a big reason for picking Python as well. And we said no magic. And by that, we mean that it should be clear from the statements that they write what happens. There shouldn't be any libraries or frameworks that do fancy graphics or things that happen without you knowing exactly what happens. So pretty plain code, no extra help from anywhere. And we also decided to make the minimal subset that we could use, so we wouldn't introduce too many things from Python. So what we decided on that they needed was, of course, variables, basically just integers and strings, maybe floats as well. And then for sure we wanted if statements and if else and if elif. And we wanted loops, and we decided to only use for loops, not to talk about while loops. And we wanted to introduce functions as well, so that you can compose your program into parts, which I think is like a really fundamental thing. But we decided not to use any classes because we felt that would complicate things. You don't need them in the beginning, really. And I think this was a good choice, actually. Looking back, it was enough. You can do a lot with these few things. So I'm happy we did this. And also, we wanted to emphasize that this is something everybody can do. It's not something you have to be really interested in to be able to do. It's something that if you're taught, anybody can do it. You need to practice a bit, but it's not something that's magic that only a few people can do. It's something everybody can learn. And I think that worked as well to show them that they can all write programs. So we also talked before we started, we talked about what kind of examples we would use. And so the first example, of course, had to be Hello World. And we wanted to do this in the first lesson when we both went to the class. We wanted to be able to have all the students write the program that prints Hello World and run it, so that they could all feel that, wow, I programmed today. I wrote a program that did something. And we managed to do that. And in this, together with this, we introduced variables as well. So, and how, if you have a variable, the values it has can change. And we also, of course, introduced print, and we also did input, so that you can input your name and then print hello, Henrik, for example. So that was the simple beginning. The next example we decided on to use was to make a calculator. And we thought we'd just start with an add function. So you read in two numbers, and then the add function is called, and it adds those two numbers and prints out the result. So making a little calculator. And of course, I mean, you don't need to have a function, but it's a nice way to introduce functions. And the calculator is good too, because you can expand it by having subtraction and multiplication and division. and other things as well. But of course, if you want to divide, you probably need to use floats as well. And then the final example we used was the guess the number game, and that's you generate a number from 1 to 100, a random number, and then you guess, and the computer prints if it's too high or too low, and then it counts how many tries you needed to find the correct number. So for there, we need if statements or if else, and we also need a loop, and we just did like 4 1,000 times so that it would never run out the loop. So in these examples, we managed to get all the concepts in that we wanted. So this is this we planned out before, and so when we got to the classroom, like I said, both Ulla and I went there on the first occasion, and we both took some time off work then, and we spent the first part just talking about what a programmer does. What you do during the days, explaining a little bit about the profession in general. But then we started the coding part, and we had a projector in the classroom, and we hooked up our laptops. So we basically live coded, showed them on the screen that they saw on the whiteboard. They saw our screen and saw what we did, and then we got everybody to follow our lead, basically. And so we showed them how you open a terminal. We showed them how you start the idle editor. And we taught them, type this in, print hello world, and then save the file, then go to the terminal, and then run the program, like Python hello.py, for example. And it was a really good thing that we were both there the first time, because then one of us could explain things on the computer, on the projector, and the other one could walk around and help those who had a problem getting started. Like, there were all sorts of little problems, but quick to sort out. So it was really good to be 2 people. And then, like I said, I think it was like 2 or 3 lessons. This was in the technology subject. 2 or 3 lessons a week they had for 8 weeks. And so the next time I came back myself and went through examples, and the next time Ulle came to class and went through the rest of the examples. And then they had enough to get going by themselves, and Caroline was helping them. And then Caroline was mailing us and asking questions that came up. And then I came back sometime, I don't know, week 4 or something, or week 3, and answered questions they had and showed some more. And it was really nice to be live coding as well, because then you show them that if you don't know something, you can Google it and find examples. So we showed how the process works, and adding code to the editor and running them and showing the results. Yes, I mentioned that. So Caroline mailed me questions sometimes, and I could bring up an example and mail it back to her and say, this is how you can do that. And the guess the number game was good, because the students had so many ideas on how to improve it. I mean, we had thought of some ways you could do it to make it last a bit longer, but they were just brimming with ideas what they should do. So, they wanted to count how many tries you had before you hit the right number. They wanted a scoring function, so you could be gold or silver or bronze, depending on how quickly you found the random number. How long it took you, so you needed a timer. Another good thing we added to that game was you should warn if you've already guessed the number before. So if you guessed 44 and then type 44 in again, it should say you already guessed that. And for that, we introduced a list that you add the guesses in, and then you check if the new guess is in the list, then you warn. They wanted to choose the range, so it's more than 100. Many wanted to have sounds as well, which I think is a great addition. So that is sort of a bit of magic to be able to play a sound, but I mean, it's a few lines of code and you have a sound file that you play. So you could play a sound when you guess the wrong number. And some people wanted to have a high score list, and they wanted to store the results from run to run. And so for the storing of the results, we showed them how dictionaries work. And we didn't want to like store in a format and then parse the file content. So we just used pickle to store the dict directly. And that worked quite well too. And some of them came up with their own idea as well, that they wanted to make a quiz game where you have questions and 3 alternatives, and then you press A, B, or C for which one you think is right. And then the program keeps track of if it's the right or wrong answer, and it scores, how many rights you got. So that was a really good idea that they came up with themselves. So I just helped them with the outline of what it could look like to get them going. And I should say that, so these things kept them busy for the whole 8 weeks, basically, which is kind of nice. Like they were adding functionality to their games mostly. So what we learned from this, and I asked Caroline afterwards what her takeaways were and what she thought about this whole experience, because I mean, it was new for her, and it was new for us as well, and the students. And she said it worked really well with the helping each other. The students were really good at helping each other and cooperating. And some of the students knew more, so they naturally helped a lot of other people. But she said it's almost so like they don't have time to work on their own programs because they're helping all the other people. But it was nice that this cooperation worked so well. And she also noticed that soon, or pretty quickly, several students knew more than her. And she said you have to be aware of that, because it makes it a bit weird when they know more than the teacher. And she also said that it's hard for her to know how to grade the programs, because she didn't always know how things work. And she also said that it's she spends her time getting everybody busy, so she doesn't have so much time to do the tasks herself. So that's another reason why it's hard to grade the programs after. She double-checked with me some things that just made sense, more complicated loops. Yes, if you use list or dicts, that's more advanced and stuff like that. She also said that the pace was much higher than if she had done it. She said she would have done it much more slowly, but we kind of just jumped into the water and started coding on the first lesson and went pretty quickly. And she said that most of the students, they thought that they understood the whole way, but once they were supposed to write their own programs, then they kind of realized that they hadn't quite grasped everything. But she said it was good. It was nice that it was this way, but it's not how she would have done it. And like I mentioned, we ran the programs from the terminal as well. We didn't want it to be that you run it from some environment. We wanted to be quite clear on how the program is run as well. We didn't use any version control because, I mean, that would take time from the actual programming. And it's complicated as well with version control. But we told them just to back up their files once in a while. That worked fine. We used Python 2.7 at the time, but I wish we'd used Python 3 because it would have been much easier. We had lots of problems with Swedish characters when they were reading and printing. So Python 3 for sure. We helped them with troubleshooting tips as well. Like, for example, for guessing the number, try setting the number to a fixed number, 57, for example, and then see how your logic works. And when it works, then you go back to using a random number. Some things that the students had problems with, lots of missing colons, missing brackets, missing or wrong indentation. So that's the first things you look at. And it's hard with the error messages sometimes for the kids to understand what it actually means. Not saving the file when you try to run it, but that's something I've done myself sometimes, or having an older version. But that's something to look out for as well. In idle, you have like a star if it's not saved. Mixing up percent and ampersand. Some of them, they just thought they couldn't differentiate between them, so they used the wrong character. Strings versus integer. If you're gonna, for your calculator, you have to explain that a string of 5 is not the same as the integer 5. And that happened quite a bit too. Right. So I thought this was a great thing because it worked so well. Caroline said lots of the kids were really excited and they wanted to program next year as well, and they were really happy about this. And I thought it worked really well too. We spent some time in the beginning, but it wasn't so much, and Caroline was very happy to get the help. And so overall, it was quite a success, I would say. Yeah, many students really liked it. And we asked them at the end of the course, they should take their programs home and show them to their parents, and they should show the program and explain how it works. And many were quite proud of the things they'd done. And I mean, it's that joy you get from like having written a whole program and showing it off to somebody. So I think that was a good thing to make them do as well. And I think for all the programmers out there, consider volunteering, because I think a lot of schools would be very happy to get the help. And it doesn't have to be a lot of work. All the examples we used, they're on GitHub. I'll show the link later. So you can use that if you want to. But I also thought it was really nice to be in my son's class and see how they were in the classroom situation. And I learned what they thought were weird things in Python, which was really good too. They said for Python 2, like, why doesn't print have parentheses around it? And I thought, yeah, that's a really good question, actually. And now it's changed, fixed in Python 3. So all the code examples are here on GitHub. And there is also a blog post I wrote after this that you see the link for there. And if you just Google for programming for grade 8, you'll find it, I think. So you can take a look there if you want to. But I really think it was nice to have had this experience, and they were so happy that we helped them. Right. So any questions?
Henrik, thanks a lot for an excellent and inspiring talk.
Yeah, thanks.
There are no questions on YouTube, so let's wait for a minute while the watchers can.
Yes, sure.
Can do something. But I actually have a question myself.
Yeah.
So there were these in the education tracks. There were a couple of talks regarding the math. And in your opinion, is that so? What should be the priority of school student? Math first, programming second, or they should start together, or perhaps learn programming first? What could you say about that?
Yeah, I think there's a lot. I think basically you don't have to have it connected to math. I think you can do some things in math easily with Python, but I don't think it has to be like in this case, like the quiz programs, for example, are basically not math related, but a lot of the kids like doing those. And I don't know, like, guess the numbers maybe slightly mathy, but I think that I don't think you have to connect the math and the programming, even though I think in Sweden it's supposed to be included in the math and technology classes. But I think it works well to do other kinds of programs as well. But if you want to use it in the math classes as well, that's fine, I think. But it doesn't have to be like that.
No, yeah, I actually meant, so you have answered my question. I meant the fundamental math and programming. Okay, but then you mentioned the Scratch and some other and Lego.
Yeah, Lego robots as well.
Do you think, are they doing good for students programming wise, or they're teaching them maybe not the right things to become a professional software engineer?
Well, yeah, I mean, I think that the goal isn't for them to be professional developers. I mean, the goal is just to show them how programming works. And I think they had done both Scratch and Lego robots, but they were kind of tired of that, and they wanted to do like real programming. So they want to do text programming, and I think maybe it's natural, like they've done that, but they knew there was something more. And I mean, these were grade 8, so they were like 14, so they're quite old. I think that when they're younger, maybe it's Scratch is maybe the better fit.
Okay, thanks a lot.
Yeah, you're welcome.
No questions from YouTube audience yet, so I guess we have 3 minutes of rest, and then we can join the final summary. I guess it might be short and interesting.
Yes.
So thanks a lot for being with us. It was really inspiring and interesting. With that, bye-bye.
Yeah, goodbye. Goodbye.